Okay, so today we are doing addition and subtraction of rational expressions, part 2. So it is pretty much the same as yesterday, except we're working with more complicated questions now. So yesterday we started by adding like actual fractions. Today we get to start with like this. So one of the biggest differences about what we're doing today is that our denominators are going to have a common factor. So it's not going to be as simple as being like, oh, okay, I'll go like 5x plus 5, 2x plus 2. Okay? So when we do our questions today, our first step is to see, can our denominators be factored at all, or is there like a greatest common factor in them? So for example, with this one, we go, okay, well, 4, we say, oh, well, this has a GCF of 5. So we'll go 5 times x plus 1. And then we notice, oh, well, this one has a GCF of 2. So then when we look at this and we try to find our LCD, we should go, okay, well, these both have x plus 1s. So we know our LCD is definitely going to have an x plus 1. Then we say, okay, but it also has a 5 and a 2. So our LCD is 10x plus 1. Okay? So then when we're trying to make our two terms have a denominator of 10 times x plus 1, we look at the first one and we'd go, okay, well, this is 5 times x plus 1, so I'm going to multiply everything by 2. So we go like this. Okay. And then the second one, say, well, this is 2 times x plus 1, so to get 10x plus 1, everything is multiplied by 5. Okay. Yeah, so we don't have to do that because we can just multiply that 5 and that 2, and then we can keep that pulled out. So we want to keep it in factored form for this one, basically. So we go, okay, so 4 times 2 plus 3 times 5 all over 10 x plus 1. So that gives us 8, 15, 1, gives us 23. Just like that. And at the end, you always want to see if you can put it into lowest terms. But we know that 23 is a prime number. Okay? And then so we also always want to find our non-permissible values. And so in this question, it doesn't really make a difference, but you always want to look at what it is before you simplify anything at the end. So with this one, like, we didn't have to simplify it at the end at all, so we don't worry too much, but always look at what your original denominators were. So here we go, okay, x plus 1 cannot equal 0. So our non-permissible is x minus 1. Okay, so just remember for your non-permissibles, always look at your original denominators. Okay, so let's look at this one now. So for this one, we're going to start it the same way. We're going to look at if we can factor either of our denominators. So we can't really factor x squared. But this one here, we can say, oh, well, we do have a GCF of x. So we'll go, okay, x plus 2. So if we're trying to find our LCD now, I think, okay, well, the first one has an x squared, so I know that's definitely going to be in it. And we look at the second one and say, okay, well, this has an x, and this has an x, so that's good. This also has an x plus 2. So our LCD is going to be x squared, x plus 2. Yes, Aaron? Because when we look at it like these are the two factors, an x and an x plus 2. And you can make an x squared by multiplying it by another x. Okay? But you can't make an x squared an x plus 2, if that makes sense. Okay? So we say, okay, well, this is our LCD, so we know this first one needs to get multiplied by x plus 2 on the top and the bottom. And this one, it has an x plus 2 and only one x. So we're going to multiply it by another x on the top and the bottom. So we can simplify it and we get, okay, so we know our LCD is x squared, x plus 2. And then on the top we have 1 times x plus 2 minus 1 times x. So we get x plus 2 minus x all over that lowest common denominator. And then we get to go, okay, x squared, x plus 2. And to simplify this, we can go, okay, well, this is the same here as having like x minus x. So those are going to cancel out. And that leaves us with just 2. Okay? So we can't simplify this anymore. So this is our final answer. And then to find our non-permissibles, yeah, so we want to use this in factors. So that's a really good suggestion, just to do that. As soon as you have those denominators factored, find those. Because on a test, if you're like stressed out or you're running low on time, that's a step you'll forget to do. Okay? So it's always good, as soon as you have those factors, you can find it. So we know, okay, x squared cannot equal 0. So x cannot equal 0. We have x cannot equal 0 there. Then we have x plus 2 cannot equal 0. So x cannot equal negative 2. Okay, so let's do example number 2. Okay, so this one is kind of nice because they already have our denominators factored. So our first step is done for us. Okay, so let's figure out what our lowest common denominator is. Okay, so we know our lowest common denominator needs x plus 1, needs an x minus 2, and we say, okay, well, it needs an x plus 4, and we already have an x plus 2, so we don't have to worry about that, or x minus 2, thank you. Okay, so we can look at this and say, okay, I want to make both of our denominators equal our LCD. So to do that in our first term, we say, well, we have an x plus 1, we have an x minus 2. We need to multiply both the top and the bottom by an x plus 4. Okay? And then for the second term, we say, well, we don't have an x plus 1, so I know I have to do that automatically, but we do have an x minus 2, and we do have an x plus 4. So we're going to get 5 x plus 4 plus 2 x plus 1 all over our lowest common denominator. Okay. So then this just becomes something where we have to expand it and simplify. So we're going to go, okay, well, 5 times x, 5 times 4, 2 times x, 2 times 1. So you go 5x plus 2 plus 2x plus 2. Okay? And then all over that common denominator. And so all we have to do is gather our like terms on top. So we go, okay, well, we have 5x and 2x, so that's 7x plus 22. And then we have no GCF in our numerator. We can't factor it anymore. Pardon? So for example, if like it was something like 7x plus 1 in our numerator, then we could cancel them out. So we'll be doing some examples like that coming up. Okay? So we should look for our non-permissibles. So we want to use our factors from our original. So we'll go x plus 1 cannot equal 0. So x cannot equal negative 1. X minus 2 cannot equal 0. So x cannot equal 2. X plus 4 cannot equal 0. So x cannot equal negative 4. No? Yeah, and then the negative, or the 2 would be the same. So we only have 3 because even though we have 4 factors, 2 of them are the same. So in the numerator, we don't worry about it because if the numerator equals to 0, that's okay, but the denominator cannot equal 0. Exactly. So if the numerator is 0, it just means the answer is 0. Okay, so let's flip over the page, and we'll do example number 3. Okay, so this one is actually somewhat similar to the one on the quiz today. So this is like a review from yesterday as well. It was a tough question on the quiz. It was okay, it was character building. Okay, so the first thing we want to do is factor our denominators, right? So this is going to become p minus 1, p plus 1, under 4. It's a difference of perfect squares here. Okay, so then we get p plus 1 under 2 on the other side. Okay, so can someone put up their hand and tell me what our LCD is? Our lowest common denominator. Okay, Josh? And? Perfect. Exactly. So this is awesome because we already have that on this side, so we don't have to do anything more with that first term. But in our second term, p minus 1 on the top and the bottom. Yeah. So then we get to go, okay, so this becomes 4 plus 2, p minus 1, all over p minus 1 and p plus 1. Okay? And then we get to expand it. So our 4 is good, but our 2 needs to be distributed to both of these terms. So we go 4 plus 2p minus 2. Okay? Like that. So then when we simplify this, we get, okay, well, that's 2p plus 2 for p minus 1 and p plus 1. Okay. So can someone who notices something about our numerator put up their hand? Okay. Is there GCF? Exactly. So we have okay, so we can pull that factor of 2 out. And then we can go, oh, well, we have a p plus 2 or a p plus 1 in the top and the bottom. So we can divide it out. And then get 2 over p minus 1. Okay, so they also ask us to state the non-permissibles. So how many non-permissibles should we have? Good job, guys. The last class said only 1. So well done. Yeah, so we have so p cannot equal plus or minus 1. Okay, so we're just going to do b for example number 4. Okay. So So can I have someone put up their hand and tell me what's the very first step we should do? Even before LCD. Yeah, exactly. So we want to factor both of the denominators because we need to do that to find our LCD. So you go y minus 1 and y minus 2. Do a lot of it. Yeah, I can like do faster though than even by the time I find. Okay, so we need everyone listening and watching. This question's a good one because it shows every single step. Okay? So we break it down into our factors. Can someone put up their hand and tell me the next step? Yep. Oh, good job, Michaela. So Michaela suggested, since we haven't factored right now, why don't we find the non-permissibles? So that's a good idea because I have a sneaking suspicion some things might be canceling out of this later. So we'll go y minus 2 cannot equal 0, y minus 1 cannot equal 0, and y plus 2 cannot equal 0. So y cannot equal plus or minus 2, and y cannot equal 1. So that's out of our way now. We don't have to worry about it. Feels great. Okay, so now we found our non-permissibles. What should we do next? Can someone put up their hand and let me know? Yeah, exactly. Okay, so should be quiet in here. Okay, so we have y minus 2, and we know we need a y minus 1. And we say, oh, well, we already have a y minus 1, and we have a y plus 2. Okay, so we can go, and we say, for this one, I guess, for this one, we have the y minus 2 and the y minus 1, but we need to multiply it by the y plus 2. And for this side, we say, okay, well, we don't have the y minus 2, so we're going to do that right away. But we do have the y minus 1 and the y plus 2. So we can go 1 times y plus 2 plus 3 y minus 2 all over our LCD. And then we want to distribute it. So our 1 is really easy to distribute. But then we also have to distribute the 3. So we get y plus 2 plus 3y minus 6 all over that LCD. And then we get to simplify it. So we go, okay, so that's y plus 3y, so we get 4y. And then 2 minus 6, so minus 4. I told you I had a sneaking suspicion something would cancel out. Okay, so can I have someone put up their hand and tell me what our GCF is? Josh. Lucky number 4. Let's go. So we gotta go like this. And we say, oh, well, this cancels out. So that leaves us with y minus 2, y plus 2 under 4. And we've already found our non-permissible, so the question is done. Yes? Sorry. Oh, like FOIL this into the difference perfect squares? You can if you want at the very end. It's nice to keep it in factored form because then you can see this sort of stuff here. But if at the very end, if you like to have it in FOILed form, go ahead. Okay. Josh, did you have a question as well? Good questions, guys. Yeah, it's just good practice. It takes like 30 seconds, not even usually. Okay, so let's flip the page. And this is going to be our last example. Okay? So let's be super focused, because this is kind of a complicated one. So no one should be wearing headphones during the lesson. Okay? So what is our first step? Can someone put up their hand and let me know? Yeah, Lucas? Yeah, factor it all, top and bottom, right? So let's go. X minus 1, x plus 2. And on the bottom we have x minus 1, x minus 4. Yeah. Okay, so everyone should be completely quiet. Okay, so what's the question? Okay, so I'm just getting these from factoring this. Okay, so this is just like type 1 factoring that we learned in the factoring unit. Okay, so on this side, we get x plus 4, x plus 6. Okay, so what is some things we notice about this? Can someone put up their hand and tell me? Kelsey? Yeah, we have some things we can cancel out, even right at the beginning. So it's kind of nice to cancel things out at the beginning, because that means we're going to be doing less work as we go through it, right? Yes. Yes. Good catch. Yeah. Exactly. I changed this one here, the x minus plus 2 to x minus 2. Okay? So, can everyone please be quiet? Andrew, turn around. Sam. And Kelsey, do you want to repeat what you said? Yeah, so even before we cancel anything, remember, we need to find non-permissibles for the original equations. So we go x cannot equal 1, x cannot equal 4, x cannot equal negative 6, x cannot equal negative 2. So once you find your non-permissibles, then you can go like this. Okay? So our equation becomes a lot easier to work with then, because we just have x minus 2 over x minus 4 minus x plus 4 over x plus 2. So now it's time to find our LCD. And you can see that, oh, well, we need that x minus 4. And we need an x plus 2. So this is like the problems we were doing yesterday now, where you just go, okay, x minus 4, x minus 4. And then you got it. You got to FOIL the tops. The bottoms you can leave factored. That's fine. But FOIL the tops. So we get x squared plus 2x minus 2x minus 4. Right there. And then in this one, we get x squared plus 4x minus 4x minus 16. So one thing that makes it even easier before that step is that I can notice that this and this are both differences of perfect squares. So when they simplify, we get x squared minus 4 minus x squared minus 16. Okay? Yeah. And then so we get negative x squared plus 16. Just like that. So then, okay, so